So gradient of a vector, this is the formula for gradient of a vector. AB is equal to XY. If you want to find the gradient from a matrix, you can directly flip it. And this is how we can find the gradient. Even though it is not a very official method, but it takes a very less time. It's a very quick method of finding the gradient. So let's make our first concept. If a column vector is given, flip the column vector to find the gradient. You have to copy this screen.
Okay. Okay.
Remember, you cannot cancel the numbers in a matrix. You cannot cancel the numbers in a matrix. It is not a fraction, it's a matrix. Matrix means these two numbers are written separately. So you have to copy this rule also.
Okay. Okay.
When two vectors are parallel, their gradients are equal. When two vectors are parallel, look at the rule number 2. When two vectors are parallel, their gradients are equal. So in order to make the vectors parallel, you can equate them, you can equate their gradient. So copy rule number 2.
Okay. Okay.
Do you have the PDF?
Yes, just 2 minutes. I need to find it. Yes, okay.
So question number 8.
8, okay.
Given that 8 minus 6 and 2p are parallel vectors, find the value of p.
Given. Do we cross multiply? Oh, sorry, the gradients will be equal.
Yes, find the gradient for both of them. Rule number
Yes.
2.
Yeah. Okay.
Then then solve question number 9. Same method.
Okay. 12 multiply 3 over minus 9.
Look at the working.
Yes, I got the same answer.
If the gradient of two vectors is not the same, it will mean the vectors are not parallel. I said in the start of the session that remember to make a separate register for nodes. And I hope you are copying that.
Yes, sir.
Remember to keep a separate register for nodes.
Yes, I did.
Okay, good. Now copy this in the notes.
Okay. Okay.
If two gradients are not equal, if two gradients are not equal, if two gradients are not equal, it means that the two vectors are not parallel. Now I'm putting rule number 3. Rule 3 says, which is a very important rule, and CI own it a lot. When two vectors are parallel, they can be equated by a constant. What it means, for example, that two vectors two vectors are parallel, AB parallel to PQ. AB is equal to, I have removed the parallel sign and I have put a constant K. AB is equal to K times PQ. If two vectors are parallel, they can be equated by a constant. This rule is very important. You have to copy this now.
Okay. Sir, 1 second. I just need to open the door.
No problem.
Yes.
So now copy it.
Yes, I'm done.
So this rule means that you can equate the two vectors. You can equate the two vectors if they are, parallel, but you need to put a constant. I am doing question number 8 again. I'm doing question number 8 again with this new method. So you have to copy question number 8 again.
Okay.
Second method.
All right.
What the method says, you have to remove the parallel sign. You have to remove the parallel sign and you have to put
a constant.
Yes, you have to put a constant. Now you have to start this step using the
Okay, 1 second.
the template we have copied.
So we will remove the constant parallel and add K.
Remove the parallel sign and put a K there.
Yes. Okay. Okay.
Now solve it and get the final answer. I got the value of K as 4.
Yes, I solved it. I got the same answer.
And then put it back to get the value of P.
So we will get okay, yeah, -3/2.
Now question number 9 again for the new method.
Okay. We replace the parallel with a K.
Yes. So repeat, do the same step, huh? Same step.
Okay. Okay, I got 7.
Compare the answer.
Yes. It is right.
Now, copy this in the notes register. K cannot be taken on any side. K can be taken on any side of the equation. It's not necessary that it is always on the right side. K can be taken on any side. Please copy this in the notes. Try to keep one separate notes register throughout the remaining session.
Yes. Okay.
Now we are moving this forward to our next title way, how we can tackle questions in this terminology when he uses the data in this form. But we need to read the question. This is question number 19 in the same sheet. Look at this question. Remember, in the paper printout, he will not be underlining small letters. He will be printing it a bit dark. U is a vector, V is a vector. U is equal to KV, where K is a positive constant and V modulus is equal to 32.5. Find the values of K, S, and T. You have to copy this.
Okay. I think I have this in the file.
Sorry?
I think I have this in the file.
In the file.
Yeah.
Obviously, you're not supposed to copy the question, definitely. Just read
Okay.
the question.
Yes.
First, make the data.
Oh.
First, make the data like this.
All right. One.
Now let's start the question. And I hope you have copied it. This
Yeah.
vertical double line means magnitude. We are willing, they have given us the magnitude. Sorry.
Will we use rule number 3?
No. This is basically a different question, slightly a bit tricky one. You have read that you need to find K, S, and T. Okay, now when you start it, when there are two or more unknowns, it's a rule of maths. Always make equations, then solve the equations simultaneously. Now you have to copy this left-hand concept in the notes register.
Okay. Okay.
Now we have done this we have made this concept. Now I'm starting it. I'm using the question has given me an idea that U is equal to KV. Remember to underline the small vectors. I have placed U, I have substituted V, and now I have to solve it like a matrix multiplication. Look at this working. As there are two unknowns,
Yeah.
I should try to get it in a form of you see two equations, you can say.
Oh, okay.
Now let's use magnitude. The formula for magnitude is under root s square plus t square. Now copy these two steps and put the value and try to find the value of k.
Okay. What will you write in the place of S and T? 12 or 5?
No, from equation 1 and 2 now.
Okay. Will the answer be 13?
Acha. I'm putting I'm taking the value of S, I'm taking the value of T, I'm also taking the value of V. I made some curly arrows here.
Oh, okay. Oh, all right. One second.
So I have substituted the values, and after taking LCM, I got an equation.
Okay. I just didn't divide the 13 by 32.5.
No problem. You can check it and rectify the answer if there is a difference.
Okay, I got that.
After getting value of k, put them back to get the value of s and t.
Okay.
Now we are back in our, we have to back in our notes section, and do not use k if question already has used it. This is a very interesting trick. Examiners know that majority people use k as a constant. So if they give the k in the question already, then you should not use k, because then obviously the two k's will multiply or divide. So this is a it's a very simple but very tricky question rule. You have to copy this.
Okay.
K can be added on any side. It doesn't matter. Now we have to give a new heading. This is a rare topic. It does not come in the paper 4 or 2 regularly, but it's there like a topic: equivalence of vectors. When two vectors are equated, we can compare their coefficients. You have to copy this screen.
Okay. Okay.
Now I'm putting the concept here: 2x is equal to ax. Then it means a is equal to 2. A simple, both are x, so you can compare them. Now you have to copy this.
Okay. Okay.
Now look at this example: ax plus by, ax plus by is equal to mx plus ny. A is equal to m, b is equal to n. Compare x with x and compare y with y. It's called comparing the coefficient method, and then you can find again, remember that small letters, if they are vectors, should be underlined. Constants are not underlined, but vectors are always underlined. So copy this example.
Okay. Okay.
Now look at another example. When you can compare the vector in this way. You can compare two vectors in this way. X will be compared with X and Y will be compared with Y. You have to copy this now.
Okay.
So how you compare it? You compare X with X.
Yes, and Y with Y.
Now look another example. You have to copy this example.
All right. Okay.
Now see question number 21.
Okay. Will we compare x with x and y with y?
Yes, right. You have to compare like variables, x with x, y with y. This is the working. And I just have to say Asr Namaz here. Please complete this working. We can get the answer, then discuss it. I'm just coming.
All right.
Compare the answer, what answer you are getting.
Okay, just one.
I'm getting 7.
40. Okay, yes, I'm also getting 10. And for S,
Getting 7?
oh yes, I'm getting 7.
Good. Now we are moving towards our main topic of this chapter. This is the main topic and this is the core of this chapter, addition of vector. This concept is also coming from O-level physics, that vectors can be added by a rule which is called head to tail rule. Vectors are added by a rule which is called head to tail. And when you join them head to tail, vectors are said to be added like this. Now look at the first vector AB. When it finishes, the BC comes there. The output is a vector which is called AC. Now AC is the resultant vector. AC is the resultant vector. It is like a physics concept that you travel A to B and then you travel B to C. Overall, you travel A to C. Overall, you travel A to C.
Yeah.
Now you have to copy this screen.
Okay. Okay.
This is called addition of vectors. Now look at this screen. I move the red vector to the right, so it becomes head to tail. The purple vector is the resultant vector. The resultant vector is always tail to tail and head to head. But the vectors being added are always head to tail. Now, when
Yeah.
you add vectors, like for example, you can join them. PQ plus QR is equal to PR. This is a letter language, but if you carefully see PQ and Q, so Q is connecting, Q is the connecting point. Look at AB plus BC plus CD is equal to AD. Achha, when you write equal, then you notice that the first letter and the last vector are joined. MN plus NP, MN plus NP is equal to MP. This is a very important skill of this chapter. And after practice, even you will be able to write these equations just looking at the letters. You have to copy these examples, only left-hand side examples.
Okay. Okay.
Now, look at the arrow language. Head to tail means being added. Now, look at this diagram and you tell me what would be the equation of this triangle? Head to tail being added.
Okay. Um, AC plus AB equal AC.
A plus B. Look at the head to tail and tell me again.
A plus B plus C plus B equal A plus C.
A plus B is equal to C. Good. Head to tail add, head to head resultant. You have to copy this.
Okay. Okay.
Now, look at the left-hand side. Can you tell me the equation?
It will be P plus R equal Q.
P plus R is equal to Q. Good. Now try this. No need to copy. Try this.
A plus C equal B.
C plus B is equal to A. Look at the arrow.
Oh yes.
Now solve this left-hand side.
Uh, Q plus R equal P.
It's very interesting. It's not equal to anything. It's equal to 0. Can you tell me why?
Because each arrow is connecting each other, same direction.
All vectors are in head to tail, right?
Oh, yes.
All vectors are in head to tail format. Now, this is the same. If we reverse the direction of a vector, the sign of the vector reverses. You have to copy this.
Okay. Okay.
Now see the concept midpoint.
For
Midpoint of a vector. Give this heading.
okay. Okay.
Now look at the point. If you mark the midpoint, suppose the whole vector is u, underline u, then half of the vector is half u. Logically, why? Because it is in between the two vectors position. Now you have to update the same screen.
Okay.
Now you have to give a new heading in the notes, parallel vectors with unequal magnitude. Give this heading.
All right. Okay.
Now look at the two vectors. One is A and the second is 2A. If two vectors have same common letters, they have both are having A here, it means that they are parallel, only numbers are different. So 2A means twice. 2A means twice, so it's double in size. So now copy this screen.
Okay. Okay.
Look at the example, B and 1/3 B.
Okay.
Now you have to copy this left-hand
All right.
side.
Okay.
So we are on our last concept for today.
Okay.
When vectors are parallel, their letters are the same, only coefficients are different. Like B and 2B, their letters are same, but numbers are different. So we keep it up to here, and we'll inshallah continue in our next class.